Hi guys, I'm Engineer Hason and welcome to Derived. So in this video, we're going to discuss the straight line motion and the derivation of formulas. So as you can see, let us have a recap on the three basic equations of the straight line motion. Although we are already familiar on these three equations, we already memorized this since physics until our engineering dynamics. So just let me show on how to derive this formula, since my channel is all about derivation, and that's why this is called derived. Okay, so let us consider this particle of not a perfect spherical that starts from point A going to point B. Of course, when it comes to point A, it has a velocity v sub o that signifies the initial velocity. Of course, as it goes to B, it has a final velocity vf, which is here. And of course, from point A to B, it covers a distance of s, which is your displacement. Alright. So this will be your s. And of course, velocity and distance are not the only factors that affect the motion of this particle, but also the time and the acceleration. So a straight line motion, others called it also as the horizontal motion with constant acceleration. So the formula speaks for itself because the three equations has the letter A, which is the acceleration. But if your velocity is constant, example, if your velocity from point A to point B is the same, so you have no acceleration. Of course, if A is equal to 0, just cancel it, cancel this, and cancel this one. So you will have B sub f is equal to B sub o, s is equal to B sub t, B sub o times t, and bf squared is equal to B sub squared. So taking the square root of both sides, it will become the same as the first equation. So I will just label it. Yep. Of course, in order to derive these three basic equations, there are two processes. I don't know if you have no third type, but I do have the two basic process, which is first, rather I put its letter A. We already have numbers here. So A is, of course, the velocity time diagram. And second is by integration process. Okay, sorry for my handwriting. Okay, so let us start with the velocity time diagram. So velocity time diagram, if you are not familiar on this, velocity time diagram simply describes the speed and the speed at the time of the particle. So that was simple. So velocity time diagram has this sample graph. So just take your vertical axis for the velocity and the horizontal axis for time. Of course, it is origin 0. And the area that will be formed under this graph will be your displacement. The same as s is equal to vt for the average velocity. So v times t. Of course, your area will be your displacement. So consider this particle that starts from 0. Of course, it has a value of initial velocity bo. As it increases going to point B, of course, it has a final velocity bf, which is linear. Of course, it is increasing like this graph. Of course, it covers a total time t. And we're going to proceed with the derivation. First, the first equation. So we all know that acceleration is the ratio of change in velocity over change in time. So what is your change in velocity? So that was bf minus bo divided by time minus 0. So I will not put the 0 anymore. So cross multiply, you have the at is equal to bf minus vo. Just transpose the initial velocity at the other side, and there you have it. Initial velocity, rather final velocity is equal to initial velocity plus acceleration times time. Then you will have your first equation. So second equation. So what we are going to find here is the letter S, displacement. As I said earlier, the graph that will be formed under this BT diagram will be your displacement. So we're going to divide these two into two shapes. So one is the rectangle and one is the triangle for more convenient integration. Of course, so your first area, so let us take this total area, AT is equal to area 1 plus area 2, which is your area 1 is the rectangle. So that was base times height, of course, so that was VO times T, plus your area 2 is 1/2 times base times height. So what is your base? That will be your time. Alright, first value. So your height will be, of course, this one. So what is this? That will be the difference of BF minus BO. So this will be VF minus BO. So VF minus BO will be your height and your base will be T. So are you seeing the second equation? Yes, the 50%. How about this second term? So just remember that the BF minus BO here is equal to 80. So we can insert this one in here. So your 80 will be VOT, yep, plus 1/2 times 80. Not 80, huh? That was A times T. Of course, times T again. So that was VOT plus 1/2 AT squared. There you have it. You have already your second equation. So going to check this one. Okay, lastly, we're going to derive the third equation, which is the BF squared is equal to BF squared plus 2AS. Yep. So how are we going to do this? So we are going to use also the second equation. So just insert the T. So what will be our T? So our T here, as you can see, A is equal to delta B over delta T. So we may also write this as time is equal to VF minus VO over A. So we're going to I'm going to write letter T as small letters. Yeah. So just insert this letter T into this and into this and into this. So your area T, which is also your displacement, is equal to, we're going to put S here, I forgot. So VO, what is your T? Difference in velocity divided by the acceleration plus 1/2 A BF minus BO squared over A squared. Okay, so since it's sorry, I'm going to erase this one. Yeah, letter A. So this will become parenthesis BF minus BO squared over A squared, of course. So cancel A over A squared, may matitira kang A sa ilalim. Yeah guys, I'm going to practice my English fluently and straight, but right now I'm just going to speak with mixed English and Tagalog, so I'm very sorry for that. So you have your 2A as your denominator, so this basic math, your denominator will be 2A, 2 times the above, 2 VO VF, so distribute minus 2 BO squared plus, of course this is binomial expansion, just VF squared minus 2vf bo plus bo squared. So we're going to add or subtract all the similar terms. And what are those? I'm going to use red ink. So this will come 2 bovf minus 2 bf bo. Negative 2 plus 1, of course you have negative 1. Okay, I'm going to use black. So your area total, that is also the letter S, is equal to bf squared, retain, of course negative 2 plus 1, bo squared over 2a. So cross multiply, you have b final velocity squared is equal to transpose the negative on the other side. So you have the bo squared plus 2as. Okay, and there you have it, guys. You have your 3 equations of straight line motions. So yay. So we derive it. So guys, thank you for listening for our first process on the derivation of the formulas for the straight line motion. On the next video, we're going to use the integration process for our formula derivation. So sa mga tatanong kung bakit kailangan natin mag-derive, that's because para sa akin mas lamang ang alam kung ano ang pinagmulan ng formulas. Para kapag may exam at wala sa given yung question, kung nasanay ka na lapag lang agad, so kung gusto mo mag-level up, so subscribe ka sa akin. So I'm going to show a lot of derivation of certain topics in mathematics and engineering. Okay, so thank you for listening. We're going to proceed with the second video, which is the integration process of derivation of formulas of straight line motion. Bye. Thank you.